In this video, we're going to practice an example of differentiating a base A logarithm in an example where we need to apply the chain rule to do it. So in this case, it says find d dx, or in other words, take the derivative or find f prime of x for f of x equals the log base 5 of the cosine of x. So here we have f of x equals log base 5 of the cosine. And what we want to immediately recognize is that we have a function composition. We have the cosine function inside of or being composed with the log base 5. So one way we could handle this would just be to do a simple u substitution and say u equals the cosine of x, which would allow us to write this as f of x equals log base 5 of u. And then we apply the derivative formula for log base a that we developed in the previous video. So we could say f prime of x is going to equal 1 over, and from the formula we developed in the previous video, we get the natural log of the base times the input to the log base a. So in this case, the input to log base 5 is the function u, but because we have a function inside another function, we need to multiply by the derivative of that function. In other words, we need to apply the chain rule. Notice we're getting that crap prime over crap form. That's characteristic of the derivative of the natural log with a tweak factor, the natural log of 5. And so once we do that, we need to take one more step. So it's 1 over the natural log of 5 times u, but u is just the cosine of x. So natural log of 5 times cosine x times u prime. But we have the cosine function, and the derivative of cosine is negative sine. So we get times the opposite of the sine of x. So we can simplify this. We have negative 1 over the natural log of base 5. And sine over cosine from trigonometry is the tangent function. That's the identity for tangent. And there we have our final result. The derivative is negative 1 over the natural log of 5 times the tangent function. Did we need to do the u substitution to do this? No, we did not. We could have simply started with f of x equaling log base 5 of the cosine of x, and then recognize that we have a function composition. So when we go to take the derivative, we know we're going to get 1 over, and it's going to be 1 over the natural log of the base. And again, this is the formula we derived in the previous video. The natural log of the base times the input to the log function. So times the input. In this case, the input is the cosine function. And then the chain rule says you have to multiply by the derivative of the function that's inside the other function. So we have to multiply by the derivative of the cosine, which is just negative sine of x, which is equal to negative 1 over the natural log of a times the sine over the cosine, by definition, is the tangent of x. So we didn't need to do the u substitution, but the u substitution can be used as a crutch so that we get it in we get our function in a form that's maybe more immediately recognizable for us.